Good morning. Today we're going over our homework, Introduction to Matter, and this is our first homework assignment, which is due in Mastering Chemistry. I will try to record videos of me doing your Mastering Chemistry assignments, not because you need them. Remember, you've got a lot of extra points available, so if you just put in honest effort, you should be able to get full credit. But the point of my object here is to make sure that if you have a question about a particular problem, you can look up how it's done and see the process that I go through. And hopefully being able to do that will reduce the amount of stress that you get when doing Mastering Chemistry, because sometimes, let's face it, it's just frustrating. It's a software and sometimes it doesn't ask the question in a way that makes sense. And sometimes it's miskeyed and you miss points, and it doesn't matter if you miss a few points because you've got a big buffer of points, but it still makes you frustrated. I can understand that. And it doesn't tell you always why you're missing the points. So having the videos hopefully will make that a little bit less of a painful experience. So here we are. We've got 8 questions in this particular homework set, and we're looking at Introduction to Matter and the way science works. And our first question is talking about thinking like a chemist. And I'm going to presume that you've read through all of this, so we're just going to look at the problems themselves. So here we are. Our first question, scientific method. We've got making an observation, proposing a hypothesis, conducting an experiment, and making a conclusion about that hypothesis. And we're going to look at this at each of these things with respect to a particular story here. So we say we have an English Springer Spaniel, which likes our neighbors' children and can play with them all day. That is our initial observation. We thought that our dogs would never dislike any children they would ever meet. That's a hypothesis, okay, which explains the observation. It says, my dog likes all children. That's why you could play with our neighbor's children all day. The experiment would then be to let your dog play with other children. So here we go. Last month, we took our dogs on a trip. We met some German tourists in a park. The dogs loved playing with the foreign family's children. So that is an experiment which tested the hypothesis. We tested it with other children, and yes, he still likes them. So therefore, the conclusion about the hypothesis was that the English Springer Spaniel likes all children. So going through here, allowing the dogs to play with the German family's children, that is the experiment. Will never implies that you haven't tested it yet. So that's the hypothesis. Whereas likes all children is a statement of fact. That is our conclusion based on our experiment. And the fact that he likes our neighbor's children, that's an observation. There we go. Next, we're going to make observations based on a product label. And we can see, for instance, that on this product label, we have active ingredients separated from inactive ingredients. The active ingredients, it tells what they do, and they give the concentrations of these. And the inactive ingredients are listed. It does not give concentrations, but if you don't know, the FDA requires the products to label these in order of quantity. So you know you've got more water in there than alcohol, and more alcohol than sorbitol solution, and so on and so forth. So based on that, we can make a couple of observations of our active ingredients here. Which of these is the highest concentration? We have 0.092%. It looks like eucalyptol is the highest concentration active ingredient. What does the mouthwash do? The purpose is anti-plaque, anti-gingivitis, which is fight plaque and gingivitis. And the highest concentration inactive ingredient is water, because it's the first one listed. So here we're making qualitative and quantitative observations. Qualitative observations like, what is this good for? Quantitative is which is the highest number quantity. All right, so here's another looking at the scientific method where you've got observation, hypothesis, experiment, conclusion. In this particular sample, you and 3 of your friends like horror movies. And you know that you were born in the same week, in the same year. So maybe that this is an astrology thing. So what should you do next? Knowing that you want to use the scientific method to test the hypothesis, then you're not going to propose alternative hypotheses because you haven't eliminated this one by testing it yet. You can't refine it because you don't have additional data from an experiment. That's what you're going to do at the end. You can perform experiments. That's what's going to do to use the scientific method to test it. And which of these experiments would best test the hypothesis? If you ask about music, then that's not really related to the movies. The best one here is going to be find other people born in the same week and ask them what their favorite type of movie is. because that takes care of the astrology portion of it, right? If you find people born in other weeks, then you're already taking people who would have different astrological signs, for instance. Now, if you find other people born in the same week and tell them and then ask them if they liked that movie, then you are leading them to the conclusion that you want them to give. And so just asking them blankly without giving them any idea like why you're asking them is a much better way to get good results. So the variable of interest is distinguished from other variables. And so here you've got your results of that particular question from 10 people born in the same week as you and your friends. And you do random people as well, just to see what you get. And what we see is that none of them particularly prefer horror movies. What did you do next? Let's see. Some of these are good answers and some of them are not. If you want to just keep going until you find more people who prefer horror movies, it sounds like you didn't get the answers that you wanted and you're going to try again. But I think that this is probably a pretty good sample. You could assume that they were lying, and you could find people who like horror movies and then ask about the birth week. But again, that introduces an element of leading the person to give you the answer that you want rather than the answer that is true necessarily. You could come up with a theory to explain why movie preference is only sometimes related to birth week. But really the best thing to do is to go back to your original hypothesis and refine it. And you might say, people who are born the same week like horror movies. That doesn't appear to be necessarily true. Maybe it's that people who are friends tend to like the same movies. That would be maybe a better explanation for why all of you who are friends like horror movies. The point of this is to show that the scientific method can be used to look at any idea. And it's not just science, but you actually probably use this in your life all the time and don't even really realize it. Okay, physical and chemical properties. Physical property of aspirin. If I burn it, then that's doing a chemical reaction. So that would be a chemical property of aspirin. I can press it into tablets when mixed with cornstarch. That's a simple mixing and not a chemical change. And so the fact that it can be compressed and hold its shape, that would be a physical property because the aspirin is still aspirin. Moderate some heart disorders when ingested. Ingesting something, eating something changes the aspirin in the process. And so that would be a chemical property. And again, reacting with something, that's a chemical reaction. So that would be a chemical property. And decomposition is a chemical reaction. So if it doesn't decompose, then this is a chemical property. So this is the only one that is a physical property and has nothing to do with changing the aspirin's identity in the process. Conversion between two states of matter. Condensation is going from a gas to a liquid, so that is a conversion between states of matter. Melting is going from a solid to a liquid, so yes. Evaporation is going from a liquid to a gas, so that is conversion, yes. Mixing, nope, that's not a conversion between states of matter. That's taking two different things and putting them together. And then freezing would be going from a liquid to a solid, so that is also a conversion between states of matter. Mixtures and pure substances. Helium is a pure substance because it is an element. A lead weight is a pure substance because lead is also an element. Wood is going to be a mixture of all sorts of biological polymers like cellulose. And concrete is also a mixture that has many different components. Which of these would be homogeneous and heterogeneous? Ooh, good question. Let's see. Wood, I think, would be heterogeneous because you can see the difference between the grains and the bark, for instance. Concrete, I think, would also be heterogeneous because concrete has the cement and the rock separately. If it was cement, you might say homogeneous, but concrete, heterogeneous. And finally, element or a compound. Helium in a balloon and lead weight, both of those are elements. Lead and helium are both elements. Now you might have different options than I do because some of these are randomized with different answers. So if your answers are different than mine, then don't be concerned about that. Just approach it from the same place and you should get it right. All right, element, compound, homogeneous mixture, heterogeneous mixture. Some of these you can look at the periodic table. Gold is an element, oxygen is an element. Some of these make sense. Fruit salad, you can see the different pieces in it. salt water, you know there's salt and water, so it would be a mixture, but you can't see the two different things, so it's going to be homogeneous. And same thing with maple syrup. You know that it's water-based and it's got sugar in it, so that's going to be a homogeneous mixture. And then these two, water and vitamin D, are not elements. They're not on the periodic table. Water is a compound, and so is vitamin D. You should know that water is a compound. Vitamin D, you might have to look up if you were not sure what that was made of. All right, what is going on here? I have some fundamental particles which consist of a red dot and a blue dot. And they're going to form different fundamental particles with either two blue dots or two red dots. So they are changing how they are bound together at the fundamental level. So this is a chemical reaction, and it's because the connections have changed between the things. They're different in composition. So we've got a chemical change because the product is different in composition from the reactant. It is a chemical change, but the product has to have the same quantity of particles as the reactant because matter is not created or destroyed in chemical reactions. A pure substance always has the same composition, and that's true then of elements and compounds, which are made of elements. So definition of pure substance is constant composition and unique or distinct properties. That's what makes a pure substance. So it could be an individual element, or it could be composed of more than one element, as in the case of a compound. If it can be broken down to its components by physical means, that's a sure sign that you're looking at a mixture, because components of the mixtures retain their original physical properties, which is why you use physical means to separate them. And that's it. I hope this was helpful, guys, and I hope you have a great day.